This year has been full of exciting releases in the GenAI space, from Claude's Sonnet 3.5 to OpenAI's O1 model to Meta's Llama 3.3 and many more. The recent launch of DeepSeek version 3 and R1 has shaken the GenAI world with its impressive capabilities, and it is said to be one of the best open source model available today. So I decided to put it to test using some prompts. Let's get started. Okay, so first I searched for DeepSeek on Google, and here are the results. I'm going to click the first one, and now we are going to start using the DeepSeek model. And of course, if you are coming to this web page for the first time, you will have to create your own login. So let's get started. We'll try a series of prompts and see how are the results. So in the first case, I'm going to try with a reasoning problem. So here is the prompt. So you are in a rush to work and you pour yourself a cup of black coffee. Basically, I want it to get a bit colder so that I can have it. It's too hot right now, so I'm giving a couple of options to the model. Whether should I add milk right away and then wait a few minutes before drinking, or should I wait a few minutes and then add a milk before drinking? So here is the result. So it is analyzing both the scenarios step by step. In the first case, we are going to add milk right away and then wait a few minutes before drinking. It says that the temperature of the coffee would decrease immediately due to mixing of the two liquids, and then the rate of cooling depends on the temperature difference and so on. The second scenario was to wait a few minutes, let the black coffee cool, and then add milk before drinking. So this is the second scenario. In this case, the temperature of the coffee would drop further, but the overall temperature would still be higher. So it is saying that waiting before adding milk allows the coffee to cool faster due to the larger temperature difference, and then the milk further reduces. So the conclusion that we get here is the coffee would cool down more if you wait few minutes before adding milk. Basically, it's selecting the option 2, and according to physics, that is favored because the temperature difference would be larger and the initial cooling would also be higher since the coffee is hotter, and then adding milk later provides an additional temperature drop. So I think it has done a pretty cool job. Let's go for the second prompt. So in this one, I'm going to ask the model to create a flow chart for a multi-agent design pattern. So some of the steps involved are break the tasks into smaller parts and then assign roles for each of these parts, execute these parts, and finally delegate and validate these outputs of these individual parts, integrate all the outputs, and finally refine the model. So in this case, I'm going to select the DeepThink R1 model, and let's see how are the output. So as you can see, it is in the thinking step. It will take a few seconds to think before it starts giving the output. So it says the user wants a flow chart for a multi-agent design pattern with the given steps. And let me start by understanding each of the steps. It has broken down the overall task into subtasks, you can see. And now for the subtask, it is going to do the execution, validation, interpretation, checking for errors, and if there are no errors, end with the final answer, right? Okay, so after thought, this is the final multi-agent design pattern steps that I get. Pretty cool, huh? So quite a good job it has done. You can see the loop also getting created here, checking for the errors. If it is valid, then that itself is the final answer, you can see. And if there is some error, means it is invalid. So it is going to the refine step where it is going to gather feedback from the model, improve the role or the process, and finally update the workflow. And then it loops back to the second step again. Pretty good. So let's try out another prompt. So in this example, I'm going to ask the model to find some grammatical mistakes. So here the prompt, analyze the content below and list down the number of grammatical mistakes in this text. So this is the text. So there are some spelling mistakes, there are some grammatical mistakes. Let's see how it goes. So as you can see, it goes sentence by sentence. So it is going to analyze for the grammatical mistakes first. And it says that the text is quite complex with advanced vocabulary, which might take some time spotting the errors and might be a bit challenging. So existence, it has found to be misspelled. In the next sentence, the subject is shifted. Okay, so the same way it is trying to find out the errors sentence by sentence. You can see very well tasks. And finally, I am able to get the complete summary of the grammatical errors for each sentence. So it has given me the errors, what kind of error it is, and the final correction for each of these errors. So existence was misspelled, underscores should be actually underscore, so it should not be plural until the spelling was again misspelled, and so on. Let's take another prompt. So in this final prompt, I'm going to take a physics problem. A weightless string connects two identical metal balls. The middle of the string is over the edge of a table, and you let go both the balls at the same time. What will happen sooner? The ball one flying off the table or the ball two hitting its side? Let's see what the model thinks. So it says, let's try to figure out this physics problem. There are two identical metal balls connected by, so it's the interpretation of the problem first. And then it is trying to visualize the setup internally. It has figured out that the ball one is hanging over the edge, ball two is on the table. Okay, so it has figured out since both the balls are identical in their masses, it is now going ahead with trying to visualize the forces which are being exerted in each of these two balls. And then it is trying to apply the equations of motion. Pretty good. And then it says ball one needs to move or fall a distance equal to the length of the string that's initially over the edge, and so on. It's reasoning back and forth, quite good. And let's go ahead and see the conclusion. You can see that a lot of equations have been tried out here. And during the reasoning, it found some mistake in the reasoning as well. So it is checking the setup again. And finally, it figured out that the string is massless and the edge is frictionless. So again, the tension should be the same throughout the string. And finally, applying the Newton's laws again, so on, so on. And after few seconds of thinking, it is still thinking. Okay, after a couple of minutes of deep thinking, it has come to a conclusion that both the events would happen simultaneously. And I think physics-wise, that's correct. So we can see the explanation step by step. It has explained what kind of setup we have, the physics analysis part of it, what all forces are acting on both the balls, and finally the time calculation is also there, the time to completion. So in conclusion, the ball one flying off the table and the ball two hitting the edge occurs at the same time because their motions are symmetrically linked to the string's constraint. Pretty good job, and I think this DeepSeek R1 model is really good in terms of step-by-step thought process, and this kind of deep analysis for physics problem, logical reasoning problems is really good. Thank you and see you in the next video.